In this problem, this is going to show you how to do the math associated with free body diagrams, or one more example of that. In the problem, I've already got a free body diagram drawn somewhere. And from this free body diagram, I have a system of summations. Some of the forces in the x direction, some of the forces in the y direction. They equal 0 and 0, so neither one of these are accelerating. And I've got t equals cosine 40h, and m1g plus m2g equals or minus t sine 40 plus v. I'm supposed to find an expression for v, and I need to do that using my givens over here, which there are a lot of givens. And my unknowns are tension and v. So when I look at this equation here, I'm thinking just solve it for v, but I've got tension. The nice thing about tension is tension comes in pairs, almost all the time that we're doing it. Just depends on how the problem is set up, but for a lot of problems like two objects over a pulley or something, I've got this pair of tensions, or in this case I've got components. So because I have the two tensions, I can substitute, and that's what this is all about. It's a method of substitutions. So what I'm going to do is I'm going to take this top equation up here, and I'm going to take it, and I'm going to solve it for, well, first thing I'll do is I'm going to move h on the other side. So let's see, that becomes positive h is equal to t cosine 40. Then I'll solve it for t, so t is equal to h divided by cosine 40. Then what I'll do is, because I'm using this method of substitutions, I'm going to substitute in for t, because that was one of my unknowns up here. So I'll get rid of that. So let's see, now this becomes, I'll write a long equation here, 0 is equal to m1g plus m2g minus h divided by cosine 40 times sine 40 plus v. So we have 40 plus v. I'm going to do a little bit of math here. I know that sine over cosine, when they're at the same angle, that's just the definition of the tangent function. So really this boils down to 0 is equal to m1g plus m2g minus h tangent 40 degrees plus v. That just makes moving things around a little bit easier. Alright, I got to solve this for v, so that's pretty easy. I'll just set v off on one side, everything else on the other. So if I put the v over here, then what that's going to do is when I move it over, well, let's see, how can I write this? What that's going to do is when I move everything on the other side of the equation, it's going to flip all their signs. So that minus h tangent 40 becomes positive h tangent 40. The positive m2g becomes minus m2g because I'm moving it on the other side. And the m1g becomes minus m1g. So there we go. An expression in terms of my givens, and it doesn't include t, and of course it has v on the one side of the equation, which is what's being asked for.